Welcome to this video on dividing by zero and why we aren't allowed to do that. Dividing by zero. Take the two expressions, 0 over 1 and 1 over 0. One of these expressions has an answer and one of them doesn't. Take a minute, pause this video, and see if you can figure out which one is which. 0 divided by anything except for 0 itself is 0. In this example, 0 divided by 1 is 0. Or we can write it as 0 divided by 1 equals 0. But what happens when we flip it and we try to divide 1 by 0? Any number divided by 0, including 0 itself, is undefined. Type 1 divided by 0 in your calculator, and your calculator will most likely say error. Error is calculator speak for an operation that is not allowed. So, on any kind of test, homework, quiz, we would write 1 divided by 0 equals undefined. That is the answer to that problem. Why can't we divide by 0? As you can imagine, this question has long bothered mathematicians. In general, people don't like being told that they are not allowed to do something. So you can believe that mathematicians throughout history have tried to find a way to divide by 0. One approach is to divide by smaller and smaller numbers that approach 0. Let's see what happens when we do this. So let's take 1 divided by a small number. So let's start with 1 divided by 1. 1 is pretty small. Well, 1 divided by 1 is 1. But even smaller than 1 is 0.1 or 1/10. So when we divide by 0.1, when we have 1 divided by 0.1, we get 10. Well, even smaller than 0.1 is 0.01. 1 divided by 0.01 is 100. As we keep going and have smaller and smaller numbers that approach 0, what happens to the value of 1 divided by this small number? Hopefully you can see that as we divide by smaller and smaller numbers, we end up with larger and larger numbers. In fact, there is not an upper limit to the value we could get as we decrease this number. So we say that the limit as we approach 0 from the positive side or the right side is infinity. So the limit of these values is infinity. In other words, it's really not limited or bounded. So this is when we're approaching it from the right side or the positive side. Notice all of these numbers that we're dividing by are positive. But what if we look at some negative numbers? So for example, -1 is a small number. It's kind of close to 0. So 1 divided by -1 is -1. Well, even smaller than -1 is -0.1. This is even closer to 0 on a number line. So 1 divided by -0.1 is -10. Again, we can continue this pattern and notice that as we divide by smaller and smaller negative numbers, these numbers are still getting closer and closer to 0 on a number line. We have larger and larger values over here, but they're negative. So what does this mean? Well, all of these values, right, you can see that they're getting larger and larger in size, but they're all negative. So they're not approaching positive infinity anymore. They are in fact approaching negative infinity. So we say the limit here as we approach 0 from the negative side or left side is negative infinity. Let's see what happens when we try to graph this concept. So remember, we're trying to get 1 over 0. Okay, we can't graph 1 over 0, but we can graph 1 over x. And then we can see what happens when x gets very close to 0. So the graph of 1 over x looks like this. So as we approach from the positive side, when we let x be positive values, okay, notice that the function, right, 1 over x gets bigger and bigger and bigger without bounds. This is actually what's called a vertical asymptote, and you don't necessarily need to know that for your class. You just need to understand that it is going to approach 0, but it's never going to get there. It can never be 0. Okay, it's not defined when we get to 0. Okay, likewise, remember we said that if we approach from the left side, when we approach with smaller and smaller negative values, okay, we're now going down. We're getting closer and closer to negative infinity. Okay, but again, we're never going to get there. This line can get what we say we call arbitrarily close. Okay, we can get as close as we want to this line, but we can never touch it. It's kind of like that silly game you might have played in the back seat with your siblings, where you're like, "I'm not touching you, I'm not touching you," and you hold your hand, hair's breadth away from them, right? And you're so close, but you're like not actually touching them. It's like that. That's exactly how this function is behaving. Okay, you can get as close as you want to the y-axis here, it's never going to get there. So we can say that 1 over 0, or really any number that's not 0 over 0, is going to be undefined.